The closer we get to the equator of our planet, the hotter it gets. From snow on the North Pole to dry deserts in Africa. These are for us humans big fluctuations in temperatures, created by our sun and the seasons that we have on Earth. But our well-balanced, small place in the universe is boring compared to the almost unimaginable conditions in our universe. Temperatures are essential for life to exist. Earth is in what we call the Goldilocks zone, the place in which a planet is at the right distance from its star, so it's not too hot nor too cold. Mars is also one of the planets in the Goldilocks zone. All the other planets are either too close or too far away from our sun. If we step outside this perfect zone for human existence and move to planets beyond Jupiter, we come across some stunning details about the different temperatures on these planets. Saturn is a very cool planet. The average temperature is almost minus 178 degrees Celsius. Next is Uranus, even colder, almost minus 216 degrees Celsius. If we move closer to the sun, the planet Venus, the hottest planet in our solar system, temperatures can reach over 462 degrees Celsius. Even though it's the planet that looks the most like Earth in size and mass, it shows how important the distance is from the sun. The sun warms our solar system and plays a vital role in temperatures across planets. On the surface of the sun, it's 5,500 degrees Celsius. The center of the sun reaches an impossible to comprehend temperature of 15 million degrees Celsius. This is so hot that if a grain of sand would reach this temperature, it would instantly kill every human in a 150-kilometer radius. Since the sun is very big and hot, it emits light, and light is energy. When the light travels to Earth, our planet absorbs the light, and this generates heat. We now know much about the temperature differences on Earth, our sun, and other planets. But what is temperature in space and beyond our solar system? First, we must answer the question, how cold can it really get in space? The short answer, absolute zero. The coldest possible temperature, absolute zero, is minus 273.15 degrees Celsius. This is so cold, all movements from atoms completely stop. Space can theoretically be the temperature of absolute zero. It all depends on what's around you. Pluto's surface temperature reaches as low as minus 240 degrees Celsius, just 33 degrees above absolute zero. Still very, very cold. The further away you travel from our sun, the colder it can get. The temperature of the cosmic microwave background radiation is minus 270.45 degrees Celsius, extremely close to absolute zero. So we can conclude the vacuum of space is not a warm place to be. But what are the hottest, non-human made places in our universe? Everything in our universe loves heat, and the hotter it gets, the more active atoms become. This can create extreme temperatures. In fact, the hottest possible temperature is more than 100 million degrees Celsius. The hottest place ever in our universe was an extremely short moment in which the temperature was 1 octillion degrees Celsius. It was right at the moment our universe was created by the Big Bang. This event was literally an immeasurably short amount of time. Temperatures were very close to the absolute hottest temperature possible before physics break down. When we go back to our sun, we know it is the burning fuel for our solar system. We know it's extremely hot, and without its massive flow of energy traveling to Earth, we wouldn't have existed. We now know a little bit more about how hot the sun really is. But is it really that hot? It turns out there are stars that are even hotter. If we travel to the star WR102, we find an extremely rare one. The star is highly evolved, very hot, and close to exploding as a supernova. The surface temperature is over 35 times hotter than of our own sun, reaching temperatures of almost 210,000 degrees Celsius. Its luminosity is estimated to be 500,000 more than that of the sun. Within 1,500 years, this massive star will self-destruct in a supernova explosion. The supernova explosion will reach a temperature around 100 billion degrees Celsius. Back to our own solar system. One day, the sun will slowly become smaller. So small, it will become the same size as Earth, but remaining its enormous mass. When this happens, the sun will be what we call a white dwarf. At this stage, the sun has used up all of its fuel and is slowly becoming cooler. Our hot sun now is only 5,700 to 30,000 degrees Celsius at its core. It will be millions of years before we even come close to something like this happening. Our sun is a middle-aged star, relatively young with lots of energy to power our solar system. We remain in the comfort of our giant center of heat for a long time. But what is the current hottest place in our universe? Let's end on a high. A Japanese satellite used an X-ray telescope to discover what we currently know as the hottest possible place in our universe. Surrounding a cluster of galaxies almost 5 million light-years wide is located a cloud of gas that is almost 300 million degrees Celsius. The theory suggests that it has collided with another galaxy at 4,000 kilometers a second, and this created enormous heat that scientists still can't get their head around. The core of our star now seems like a cold place to be. We have traveled our universe to find out that when it comes down to temperatures, it's all about the extremes. It's about the absolute coldest and hottest possible temperatures. Events that you can't wrap your head around. It's amazing we as humans can live because of our atmosphere and perfect place in our solar system. We are truly lucky. But there are more planets in the Goldilocks zone. Could there be life out there? Thank you for watching. We have given you a small look into this subject. We might have missed something. We might have gotten something wrong. Let us know what your thoughts are. We hope you stay around for another episode. Only if you like this video. Please subscribe to see more episodes.